Regression with three independent variables. That's what we'll be looking at today. In our previous video, we've discussed regression with one independent variable, and we also discussed the regression with two independent variables with different approaches, different methods. But today we are going to look at regression with three independent variables. Regression model is given us. We have y equals to beta I xi. Because we have more than one value for dependent variable and we have more than one value for independent variable. And as well, we have three parameters here. That is 4 parameters because we have three independent variables. That is a beta naught. So this is going to give us y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So these are our focus here today. Y, beta naught, beta 1, beta 2, beta 3. But these are our parameters. Beta naught, beta 1, beta 2, beta 3. The x1, x2, x3 are the independent variable, whereby we have y to be in the they are independent variable, whereby our y is dependent variable. All right. So now we'll need to do some to derive other formulas from this particular one, all right, for us to get the value of beta naught, because we are not going to get all of these together. For us to get the value of beta naught, we're going to summation all these model here, although here is supposed to be with error term, but we are not focusing on the error term in this video. We're just focusing on how to get the value for the parameters in dealing with regression with three independent variables. So now, summate all of this, we are going to have summation y equals to, the summation cannot affect this parameter, therefore it becomes m beta naught plus beta 1 summation x1 plus beta 2 summation x2 plus beta 3 summation x3. Don't forget, we're only using this to get the value for this beta naught. All right, what do we do? If you make this m beta naught the what's it called, the subject, we are going to have m beta naught equals to, therefore all of these will move to the other side here. Then we have a summation y minus beta 1 summation x1. You take this minus beta 2 summation x2 minus beta 3 summation x3. Now, if you divide all of these, by n, so we say divide through by n. If you divide through by n, we're going to have divide through by n. If we divide through by n, we are going to have beta naught equals to summation y divided by n will give us y bar minus beta 1 summation x1 divided by n will give us x1 bar minus beta 2 x2 bar minus beta 3 x3 bar. So this is the formula we're going to use to get our beta naught. So we have a y bar minus beta 1 x1 bar minus beta 2 x2 bar minus beta 3 x3 bar. Now, how do we get our formula if we are trying to get the other parameter, which is beta 1, beta 2, beta 3? Now I want to do with we are going to ignore beta naught because we already get the value of beta naught here. We're going to ignore this beta naught here. Therefore, we work directly on we start from x1, then x2, then x3. So if you have a x1 here, said x1, so summation x1 multiplied by all of these apart from this beta naught, because we already got the value of beta naught here. So this is going to give us, we have a summation x1 multiplied by y will give us summation x1y equals to summation, here we have a summation x1 square beta, although I can write it as beta summation x1 square, but let me put it that way so that all of these can come out easily. Then we have plus summation x1 x2 beta 2. We are using summation x1 to multiply all of these. Then we have a plus summation x1 x3 beta 3. Now x2 we want to use x2 to multiply all of these beside what's it called, this beta naught. We are not dealing with error term, so in this video we are not considering the error term. So now this now is going to be summation x2 multiplied by y will give us summation x2y equals to summation x1 x2 beta 1 plus summation x2 multiplied by this now will give us summation x1 square, x2 square rather, x2 square beta 2 summation x2 multiplied by this x2. Now we have a plus x2 x3, so we have a summation x2 x3 beta 3. All right, then x3 will rather give us was same x3 summation x3 multiplied by y, so we have a summation x3 y equals to summation x3 multiplied by x1, so we have a summation x1 x3 beta 1 plus x3 x2 summation x2 x3 beta 2 plus x3 x3. This will give us summation x3 square beta 3. So now if you look at this, we can present this one in matrix form to get our beta 1, also to get our beta 2, and also to get our beta 3, Now if we look at this very well, we can say this is same as, you can see all of this. What we have here is let me bracket this like this. So all of this now is our y. Y equals to, you can see we have beta beta beta, and I'm coming back to this. You can see we have beta beta beta, so we can say this is y equals to beta x I. But the beta we are considering here, beta naught is not part of it because we've already gotten the value for beta naught. This is the formula we're going to use to calculate our beta naught. So in this case now, we are dealing with from here where beta equals to beta 1 comma beta 2 comma beta 3. So therefore I will need to present this in matrix form, and I will present this in matrix form. The coefficient of beta 1 here is summation x1 square, summation x1 x2. So that is exactly what we need to bring out now. All right, so this is how we're going to run this. I don't know if we can actually see this. Okay, let me put it this way. All right, hope we can see clearly. I want to present this in matrix form. So if I present this in matrix form, we're going to have let's say we have x in matrix form. Our x is now summation x1 square, the coefficient of x here, summation x1 x2, summation x1, x3. Then we have for the second equation, we have summation x1, x2 here, summation x2 square, then here summation x2, x3. Then finally we have for the third equation, we have a summation x1, x3, summation x2, x3. Then we have a summation x3 square. You can see we've presented this in matrix form. That is the value for y. Then comma. For the beta, what we are considering here is we have a beta 1, beta 2, beta 3. We're considering 1, 2, 3. So we have beta 1, beta 2, beta 3. Then we have our y to be right from here. You can see summation x1, summation x1y, summation x2y, summation x3y, summation x3y. So I can remove these totally, then focus on this particular page. All right, now as you can see, we have summation x1 square, summation x1 x2, summation x1 x3, right from what we have here. All right, so the next thing to do, if we remember, we have y from our equation, y equals to x beta. So if you make this beta the subject of the formula, so we're going to have beta equals to x inverse y, x inverse y. So it means we're going to find the inverse of matrix x, then now multiply it by y. So now we're not going to deal with the original equation right from here. So how do we do this? Now, this is what we are considering. Before we move on from here, we want to consider this particular aspect now. So we are dealing with this y, x1, x2, x3. These are the three independent variables given to us with one dependent variable, which is y. So now for us to get this summation x1 square, x1, x2, so we need all of these columns. So which means we're going to develop this column from the existing data given. So the first column here is summation x1 square. That is, we're going to square each value in this column here. 1 square give us 1, 2 square give us 4, 25, 49, then 8 square give us 64, 64, that is an x1 square, and this give us 100. Therefore, from here we said summation x1 square equals to 100. So if we add all of this up together, we have 1 plus 4 plus 25 plus 49 plus 64 plus 100. So therefore, this is going to give us 243. Summation y, if you add up all of this value, 4 plus 7 plus this will give us 58. If you add all this column, now summation x1, if you add up all this column, that was going to give us 33. Summation x2, if you add all of this up, is going to give us 85. Summation x3, if you add up all summation x3, say summation x3, will give us 114. So we're through with that. Now we need a x2 square. X2 square, we are going to get this column right from this column here. That is square of each value here. Square of 20 will give us 400. Square of 16 will give us 256. Square of 7, 49. This 100. This 169. This will give us 361. So therefore, summation x2 square will give us 1335. For x3 square, we're going to square each value in this x3 here. So we say 70 square will give us 289. 11 square 121. 361. 576. 14 square. 14 square will give us 196, and then we have 29 square will give us 841. Therefore, summation x3 square will definitely give us 841. So we've done with square. Now what remains? Multiply column x by x1 by column x2. That's why we have x1, x2. x1 multiplied by x2. Column x1 multiplied by column x2. So if we multiply the two, we are going to have a column x1, x2. That is 1 times 20 will give us 20. If we continue that way, we have 32. That is 2 times 16. The next one give us 35. 70. 104. 190. So say summation x1, x2 will definitely give us, that is, we'll sum up all of these, we're going to have a 451. Now x2, x3, multiply this column by this column. So we have a summation x2, x3 to be equals to, now x2, x3, that is a 20 times 20 times 17, that is x2, x3. So 20 times 17, this will definitely give us 340. x2, x3, 20 times 17. Now 16 times 11, we have 176. This will give us 133, 240, 182, 551. So if we add all of this together, this is going to give us 1622. That is 1622. Now we want to deal with yx1, that is column of y multiplied by column of x1 respectively. 4 times 1 will give us 4. 7 times 2, 14, and the rest 45. 98, 88, 130. So we have a summation yx1 will be giving us, if you add up all of this together, we're going to have 379. Then we have a summation yx2 equals to yx2, that is this column multiplied by a corresponding value of this column. So 4 times 20 will give us 80. 7 times 16 give us 112. Then the rest 63, 140, 143, 247. You can confirm 20 times 9 give us 237. If you add all of this together, we're going to have a 785. then summation yx3, this value multiplied by this value, this column multiplied by corresponding value in this column. So 4 times 17 will give us 68. 4 times 11, 7 times 11 give us 77. Then 171, 336, 154. Then we have yx3, that is 13 times 19, and that will give us 377. So if you add all of this up together, we're going to have 1183. So there is one column that is not yet here. We have x1, x2. So we do not have x1, x3 yet in this column. So we are saying x1, x3, 1 multiplied by 17 will give us 17. See? x1, x3, 2 multiplied by 11 give us 22. Then that way 95, 168, 112, then we have 290. So if we prepare this, we have a summation x1, x3 will be equals to, if you add up all this value here, so we're going to have 704. You can see the way we prepare the table. So once we prepare this table like this, we are going to have the summation of all of this value. And when we have the summation of all of this value, then that is where our work begins. Now, if you remember that from the matrices that we form here, you can see we have summation x1 square, and our summation x1 square is 243. But take note of this: we are not going to use this summation of variables directly in this matrices, which means we have to do one or two things before we can go about this. So, and what do we do now? Before we go there, now let's see. Let me manage the side. We are going to calculate for us to get what is it called? Summation of all of these. But we need to get the what is it called? The value of this. We are not going to use this directly. Now we have a summation xy, x subscript iy. This is going to give us summation xiy. You can see minus summation x summation y divided by n. Then the other one is if you have this, says summation si, s subscript I, s subscript j. This will give us summation s subscript I, s subscript j minus summation xi multiplied by summation xj divided by n. Summation xi sj divided by n. Then we have a summation xi square. This is going to give us summation xi square minus summation xi all square divided by n. So this is a formula. Don't worry, I'm going to write it in the next page. This is a formula we are going to use to get exactly all this value in these matrices that we needed here. All right, so we'll move on from here. So that's what I want to do in this case now. You see, I've written all the summation that we needed here. So we start, and our focus now is on, we need from these matrices, let me circle what we need, right? We need a summation x1 square. We need x1 x2, x1 x3, x2 x3, s2 square. S1 x2 already existed here, and S1 x3 already existed here. then x2, x3 already existed, so we need x3 squared. That is 1, 2, 3, 4, 5, 6. So we needed to calculate 6 summation here in order to get exactly what we need in these what's it called, in these matrices. Then we needed all of these, plus this, that is 9. So let's begin with summation x1 squared. Says summation x1 square. If you notice, I'm using capital letter here, but in the other one I'll be using the lowercase. This is equals to summation x1 square minus summation x1 all square divided by n. So if you do this, we have a summation x1 square equals to summation x1 square. In this case, we have a summation x1 square. Where is the summation x1 square? So we have 243 minus summation x1. Here we have a 33. So we have a 33 all raised to the power 2 divided by n. What is our n? Our n is 6 because we have a 3 observation. We have 6 observations. 1, 2, 3, 4, 5, 6. Each variable has 6 observations. 1, 2, 3, 4, 5, 6. So therefore our n here equals to 6. So we have divided by 6. So therefore summation x1 square, if you calculate this, 243 minus 33 square divided by 6, this is going to give us 61.5. All right, so we've already gotten 61.5. Now summation x1 x2, we need summation x1 x2. So summation x1 x2 here is going to give us summation, sorry, I'm supposed to use capital letter here. So this is going to give us summation x1 x2 minus summation x1 into bracket summation x2 bracket close divided by n. So here we're going to have summation x1 x2 equals to summation x1 x2 here. From here x1 x2, where is x1 x2? x1 x2 give us 451. So we have 451 minus summation x1 33 multiplied by summation x2. Summation x2 is 85 divided by 6. So if we calculate this, we're going to have summation x1 x2, capital letter, sorry, summation x1 x2 will give us minus 16.5. All right, let's move on. We needed summation x1 x3, so let's be doing it accordingly. Summation x1 x3. So if we calculate summation x1 x3, this is going to give us summation x1 x3 minus summation x1 into bracket summation x2 divided by n. So if you multiply the summation x1 x3, summation x1 x3 from here, x1 x3 is 704. So we have 704 minus summation x1, which is 33 multiplied by, sorry, this is x3. Summation x3 gives us 114. So we have 114 divided by 6. Summation x1 x3 will give us, if you calculate all of these, we're going to have 77. All right, let's move on. We also need summation x2 square. Summation x2 square, say summation x2 square equals to summation x2 square minus saying summation x2 all square divided by n. And this will give us summation x2 square from here. What is it? 1335. So 1335 minus x2, which is 85, raised to the power 2 divided by n. So here we're going to have if n is equals to 6, so summation x2 square will give us 1335 minus 85 square divided by 6, and that will give us 130.83. So we have 130.83. All right. So we've gotten x2 squared. Now we need x2, x3. x2, x3. Let me use here. Summation x2. Let me use another paper so that it will be easier for us. All right. Summation x2, x3 will give us summation x2, x3 minus summation x2 multiplied by summation x3 divided by n. So summation x2, x3 will be equals to x2, x3. x2, x3, where is it? x2, x3 will give us 1622 minus summation x2, which is 85. So we have 85 multiplied by summation x3, 114 divided by 6. So therefore summation x2, x3 equals to, if you calculate all of this together, then we're going to have 7. Now the next one here is we have calculated x2, x3, so we need summation x3 square. So if we calculate x3 square, we're going to have summation x3 square equals to x3 square, x3 square. x3 square is going to give us summation x3 square minus summation x3 all square divided by n. So if we calculate this, we are going to have summation x3 square equals to summation x3 square. From here we have x3 square, we have 2384 minus summation x3, that will give us 114 square divided by 6. So if we calculate summation x3 square here, we're going to have 218. Then before we call it a day, we have summation x1y, summation x2y, summation x3y. So we need all of that in order to be able to move on. So from here, we have summation x1y, summation x1y. This will be equals to summation x1y minus this is equals to summation x, summation y, summation x multiplied by x1 summation y divided by n. And if you do this, we're going to have summation x1y right from here. Summation x1y, where is it? x1y will give us 379. So here we're going to have 379 minus summation x1, I think that is 33, multiply summation y, which is 85, divided by 6. So therefore summation x1y will give us, if we calculate all of this together, that is going to give us 16. So we need a summation x2y. This is going to be summation x2y minus summation x2 multiplied by summation y divided by n. So if you calculate this, we are going to have this equals to summation x2y, which is 785. So we have 785 minus summation x2, which is an 85. So we have 85 multiplied by 58. Summation y is 58 right from here, divided by 6. Therefore, summation x2y will definitely give us a negative value, which is minus 36.67. Minus 36.67. All right, lastly, we need a summation x3y. This will give us summation x3y minus summation x3 multiplied by summation. So summation x3y is 1183 minus 114 multiplied by 58 divided by 6. So if you multiply all of these, summation x3y will give us 81. So we've gotten the value of what we needed here, 81 minus this, and which other one again? From the previous slide, we have this, and this. These are the value we are going to use to prepare these, what's it called? These are our matrices. So therefore, I want to present these in form of matrices. So now we're going to have all of these. We have an x. If we want to use this beta equal to x bar y, so we have beta here. So let me change this one to beta. Beta equals to, and what does this beta means? It means beta 1, beta 2, beta 3 equals to x inverse. So x inverse. So we need x inverse. So, but for the x here, we have x summation x1 square. From our previous slide, summation x1 square is 61.5. Summation x1 x2 will give us minus 16.5. So you can pause and confirm what we have so far in the previous slide. So this is going to give us we says summation x1 from the previous slide give us 61.5. So here we're going to have 61.5 minus 16.5, 77 minus 16.5, 130.83, 77, 218. Inverse, then multiply by our value of y here, summation x1y give us 60 minus 36.67, 81. Then don't be surprised that where did I get all of this value? All of this value we're getting from the previous calculation. 61.5 from x1 square, you can see 61.5 for x1 square minus 16.5 for x1, x2. You can see minus 16.5 for x1, x2. x1, x2 minus 16.5. x3 square, how do we get that from the previous slide? x3 square. x3 square is 218. So we have x3 square 218. Then here we have you can see y. This is our value of y. The last value of y is summation x3y, and summation x3y is 81. So we have 81. So don't be surprised at how or where did we get all those values. Okay. If you use your calculator to find the inverse of this matrix, then you multiply it by this, you are going to have exactly what I'm going about to write here. This is going to give you 3 by 1 matrix, which is 0.814196 minus 0.182409 0.089834. So therefore, our beta 1 equals to 0.814196, this. Beta 2 equals to minus 0.182409, comma, beta 3 equals to 0.089834. Now, we should not forget that we've not calculated our beta naught. We skip our beta naught from the beginning in order for us to be able to get beta 1, beta 2, beta 3 easily. Now, if you remember from the previous slide, this is the formula we're going to use to get our beta naught. So we have beta naught. Let me write the formula here. Beta naught equals to y bar minus beta 1 x bar 1, beta 1 x bar 1 minus beta 2 x2 bar minus beta 3 x3 bar. So we said beta naught equals to our y bar, which is the summation y divided by n. And remember that our summation y is 58 divided by 6 minus beta 1. Our beta 1 is 0.814196. So we have 0.814196 into bracket x bar 1, which is 33 divided by 6, minus into bracket beta 2. Our beta 2 is minus 0.182. We have minus 0.182409 multiplied by x2 bar, which is the summation x2 divided by n. Our summation x2 is 85 divided by 6. Then we have minus beta 3 is 0.89834, right from here, 0.089834. So we have 0.089834 into brackets x bar 3, which is 114 divided by 6. So beta naught from here is going to give us, if you calculate all of this together, beta naught is equals to 6.065870. 6.065870. So which means we have beta naught, beta 1, beta 2, beta 3 equals to respectively 6.065870. Beta 1, right from here, we have 0.814196. Beta 2 minus 0.182409. And we have beta 3, 0.089834. So these are the parameters for us to get our model, which is a 3 independent variable. And if you remember, so it means right from the beginning, where it says we have y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So we know the value of each parameter here that we can slot in into this model, and that is how to calculate what's it called multiple linear regression involving three independent variables. Please, sorry, if you don't know how this is being calculated manually, that is the inverse matrices here, you can ask me under the comment section below, and I'm going to upload a video on how to calculate exactly these inverse matrices here. Thank you for watching, thank you for listening, and thank you for your patience. If you have any suggestion, please feel free to drop it in the comment section. Thank you very much.